We went over exponential functions for Unit 9, and we know that exponential functions are represented with the equation f of x equals, or y equals, either way, a times b to the x power. We know that a is going to be our initial or starting value, if you want to say it that way, initial or starting, and we know that b is going to be either our growth or decay, depending on what's going on with the graph. Usually you will see parentheses around this second value. Sometimes you do, sometimes it's just represented with like a multiplication sign. But let's look at number 1. Joe used f of x equals 78 times 1.12 raised to the x power to show the balance of his bank account over time. What does 78 represent? Well, if I'm thinking 78, I should be thinking, okay, that looks like that's going to be in the A spot. So we know that our A is going to be the starting value. Reading through the choices. The interest, the savings account earned? No. The annual interest rate of the savings account? No. The number of years the savings account has earned interest? Nope. So that leaves us with the last one, the starting balance of the savings account. That's looking good. D would be your answer for number 1. If you were talking about how much it's earning, then you'd be talking about this growth right here. So 1.12 would be a good answer for growing. But this is asking about 78, which is the starting. Okay, on number 2, what is the domain and range of the following graph? We know domain is going to be our x values and range is our y values. So when I'm looking at this graph, first I'm going to pay attention to the arrows on the end. So that's going to kind of clue me in that my domain will be all real numbers. My domain will be all real numbers. Next up, talking about range. This is something that you want to associate with the asymptote if it's horizontal. So right here, the asymptote is at y equals 2. So I know that it's going to go all the way down to almost touching 2, but it's not going to actually touch it. So our range will be y is greater than 2. Okay, third question. What is the asymptote for the following graph? Taking a look, this one's nicely laid out for us. It's going to be this dotted line up here, horizontal, so it's going to be y equals 6. It gets close to that line, but never actually touches it. Okay, moving to the back. Here's a graph that's been given to us, and then we're going to read through question number 4. Which of the following statements does not, read closely, does not appear to be true? The water temperature starts at 74.7. So if I'm starting, no time has gone by. So I'm starting when my x is 0, which means I'm looking for the y-intercept. So x is 0. I'm going to go up 74.7. Yeah, that looks like that could be a possibility. So, all right, I'm going to move past A. I don't think that is totally not true. That looks true to me or very close to being true. The temperature grows exponentially. Well, the graph looks exponential. If I look at the equation, I have an x in the exponent, so that's true. So we're looking for not true. So that one's looking good. B's looking good. The water temperature will be around 180 degrees Celsius at 9 minutes. So I'm going to look for 9 minutes. So let's see here. 9 minutes. And it's saying 180 degrees. So I'm going to follow that up. Okay, here's this point. Go over. 180, that's looking pretty good. So it's not going to be that one. And then last option, the temperature of the water decays over time. Now here's what I have to think of when I look at these graphs. If I put a bicycle at the bottom, am I pedaling uphill or am I pedaling downhill? Bicycle at the bottom, I'm pedaling uphill. That means I'm going up. If it's decaying, that's saying it's getting it smaller. So D is going to be our false statement, which is what we want for this question. Okay, 2 more questions and we're done. Number 5, the amount of dirt in a landscaping company's warehouse decreases. So that's probably going to be telling us that we're going to be working with decay at a rate of 5% per week. The amount of dirt in the warehouse was originally 95,000 cubic yards. Which of the function models, which function models the amount of dirt in cubic yards left after W weeks? All right, so originally 95,000. That's going to be our starting value. So that's our A. If it decreases at a rate of 5%, decreases, that means that B is going to have to be less than 1. So let's just keep that in mind when we're looking through these. Okay, so I'm looking for, first I'm going to use the that test taking strategy of eliminating answers that right from the start don't look good. So I'm going to focus on my A's first. My A, or the number in the A position, has to be 95,000. A, 95,000. Nope, that doesn't work. B, 95,000 in the A spot. Okay, that might work. C might work. And then D, definitely not 95,000 in the A spot. Now, here's the next thing that I can do is I can look for, if this is decaying, it has to be less than 1. So pretty simple. Which one of these are going to be less than 1? Looks like C will be our answer for 5. So take a look. What is the A? What should be the B? Or around what number should the B be? And go from there. Okay, number 6. The table to the left contains points from the graph of an exponential function. Based on the table, which function represents the same relationship? Here's what I'm going to tell you. Use Desmos, and match it up. See what's happening here. But here's how you could tell if you don't have Desmos available. Is you're going to look for when x is 0, that's your starting value, and then you're going to say how it's changing from one to the next on your y values. So like I said, utilize Desmos because it's multiple choice. You can put it in. You can match up the tables. But if you do not have Desmos readily available, you can say, okay, I know my initial value has to be 10. Well, that could be possibly A, possibly B, can't be C, and it can't be D. From here, I know that it has to grow. So this right here is going to stay constant because 1 raised to any power is 1. This will grow because it's 2. So since A is staying constant, that's going to leave us with B. Other than that, the other thing you can do is actually see what your growth is. So to go from 5 to 10 to 20 to 40, you're multiplying by 2. That'll be that growth on B.